All right, today we are looking at two topics, a very quick topic overview with combining like terms, but the majority of what we're looking at today has to do with inequalities. That's what you see in the title. And we're going to be looking at a new way of communicating the solution interval using interval notation, and we'll compare it with the old way that you're used to and then get to our examples right below. So let's start off with simplifying and combining like terms. What we're looking at doing when we're combining like terms is we're checking for two things. We're looking to see if we have the same variable as well as the same exponent. You can see in problem number 1, we have the same exponent on those r's. So yeah, those are like terms. When we get to the next problem, you're going to see that we have a lot more going on here. So you have to check both for the same variable and the same exponent as well. Now, oftentimes we might do this in our head, but let me just write down what we're thinking. We're collecting all of the like terms. So we have an r, we have a negative r, and we have another positive r, right? So that's what we're thinking in our head when we're combining like terms. Normally we don't write that step down where we shuffle all the terms around, but you can. And that's what we're really thinking of when we're combining like terms. So there's a negative s, there's a positive s, and there's a positive 2s, right? We'll combine those terms on the next line. Here we have a t, a negative t, and a negative 2t, right? So when we're combining like terms, we're saying, okay, what's the result of r minus r plus r? And that gives us just r. Here we have negative s plus s, and then plus 2s. And then here we have t minus t, they cancel out, and then a negative 2t. So there we are. Let's take a look at another example here on number 2. Before we start combining like terms, let's use that distributive property and distribute that negative 1. So we have an a squared plus 2a plus 1 to lead, and then changing all the signs. Negative 2a squared, negative 3a, and a negative 7. So we're looking at both the variable as well as the exponent. Here we have a squared, right? So a squared minus 2a squared gives us that negative a squared. Here we have an a with the same exponent of 1. So we have a 2a minus 3a. And then the constant terms result in a negative 6. Now when we are listing these terms, you always order them in descending power. So this is your a squared, this is your a to the first power, and this is your no a at all, right? It's really a to the power of 0. You could think of it that way. So always order your terms with descending powers. Again, there's a little bit more going on here as we have both p and t and a variety of exponents as well, but let's start by distributing that negative sign. So I did that first so I could make sure I had the correct sign on each of those terms at the back. Now we'll look to see if we can combine like terms. There's a lot going on here. Let's see what we can come up with. This first term is a p squared t squared, so I'm looking for other terms that have that same combination. There it is, p squared t squared. And it turns out they differ by a sign. So they're going to combine and, well, cancel out altogether. Here we have a t cubed. I'm looking for other terms that have a t cubed. There are no others, so that stays as it is. Here we have a p squared. There's another p squared, so they will combine and give us that, negative 4p squared. Excuse me, that's a positive 4p squared, as it's a 5 minus 1. Here's an 11t. There's no other terms with just a t to the first power, so that remains as is. And same with the last term. That's the only term, so it doesn't combine with anything, and there we go. So that's a quick overview of combining like terms. Let's shift gears and talk about the inequalities. So you are familiar with graphing these inequalities using open and closed circles. So when we have x is greater than or equal to some number, then we would put a closed circle at that number and then shade to the right. That's our greater than, right? That's the old way of doing it, but we're not graphing with an open or closed circle anymore. Instead, we're using brackets. So we will use a square bracket pointing to the right and shading to the right. It helps if we put on this number line the smallest number and the biggest number that we could possibly get to, negative infinity and positive infinity. Because when we're looking at describing this interval, what we're doing is we're picking two values and we're saying our solution is everywhere between those two. So we're starting off at this number. Again, we're just using a as a placeholder. So we're saying the very first number in my solution is a, and then we separate that with a comma, and it goes all the way up to infinity, and we use a rounded bracket at the infinity. So the square bracket means it is approaching a and it equals a. The rounded bracket means it goes up to infinity because that's not a real number. It's more of a concept. We use the rounded bracket because you can't ever get to infinity itself. With the next line, if your solution is less than or equal to a, well, then you had a closed circle and you shade it to the left, right? That was the old way. The new way is we take that square bracket and we point it to the left and shade to the left. Again, it helps if you put the infinities on that number line so that we can say, okay, where am I shading? I'm shading from negative infinity all the way up to a. That was the placeholder there. So I need a round bracket, a negative infinity separated by a comma. There's the value of a with a square bracket. So we're saying our solution is all of those numbers from negative infinity up to a and including a. Now, if we change the inequality to x is greater than a, then that is an open circle while shading to the right. That communicates my solution is greater than a, but not a itself. So the new a is a rounded bracket, shading to the right. And again, it helps if you put those infinities on the number line so we can see what two values to select. We're selecting the a and the infinity. So we use the rounded bracket around the a, separated by a comma. There's the infinity, and again, a rounded bracket on infinity always. So we're saying the solution is not a itself, but bigger than a and all the way up to infinity. Here, if we have x is less than a, that would be the open circle shading to the left. We're saying my solution is all of those numbers less than a, but not a itself. So the new way is a rounded bracket pointing to the left. We'll shade to the left. And if you put those infinities on the number line, we're picking the two values where we have the shading occurring. So we are going from negative infinity all the way up to a, but not including a. Here we have a compound inequality, and so instead of infinities, we're using two numbers, two values. So if we have the less than or equal to sign, that would be a square bracket at a and a square bracket at b, pointing to each other because we're shading between those two. I'm sorry, that's the new way. That should have gone here in this middle column. The old way would have been those closed circles. So let me just edit that slightly. There we go. That's the old way. That's the new way, which means my solution interval is square bracket with an a separated from the b by a comma. So this says our solution is every value from a, including a, up to and including b. Just one more illustration. What if it was a less than x less than b? So with the old way, we would have open circles with the shading in between. And with the new way, we have rounded brackets with the shading in between. And we would have rounded brackets with those values a and b separated by the comma. Now that looks like an ordered pair, but we're not plotting points on the coordinate grid. That's not a place. It's a solution interval. We're saying all the numbers between a and b, but not including a and not including b. So let's apply that new notation to some of these examples. We're going to solve each inequality. We're going to use interval notation. We're also going to graph. I actually find it's easier if we start by solving, then graph, and then finish it up by using the interval notation. So let's do it in that sequence. Here we're isolating the variable of h, so we're going to start by moving the constant term to the other side by subtracting 7 from both sides. So we have a negative 3h is greater than 1. Next, let's divide both sides by that coefficient of negative 3. Now remember, when you're dividing by that negative, you're going to change the direction of that inequality. So it's not greater than, it's less than. H is less than negative 1/3. That's the old way. For the new way, let's see what we can do here. So as we just have one value, I'll just pick a tick mark and say, hey, that's my value of negative 1/3. We used to use the open circle, but not anymore. This time it's going to be a rounded bracket, and because my solution is less than 1/3, negative 1/3, I want to shade to the left of that negative 1/3. Put your infinity on that number line so that when we then write the interval notation, we're going to pick the two values that we have shaded. So the solution is from negative infinity up to but not including the negative 1/3. That's our answer in interval notation. Here's a few more examples. Here's number 5. That's the variable we want to solve for. So let's start by moving the constant term to the other side. I'm subtracting 10 from both sides. We could do this in 1 or 2 steps. I'm going to break it up and do it in 2 separate steps. I'm just focusing on the denominator first. I'm multiplying both sides by 3. So we have a negative x greater than or equal to 15. Now I'll divide away the negative 1, and again, change the direction of your inequality. So positive x less than or equal to negative 15. Let's plot that. As I only have one value, there it is, negative 15 on my number line. Which way are we shading? Our solution is less than or equal to that negative 15. So we want a square bracket pointing to the left, shading to the left. Put your infinities on there. We're picking the 2 values that have the shaded region. So those are the 2 numbers we want. Our solution interval then is rounded bracket at the negative infinity, and at the negative 15 is square bracket. So that's our technique. Here are a few more variations on that. Here's number 6. Let's first distribute that negative 5 to the binomial. So 4 minus 5x plus 10 less than or equal to 24. Let's combine like terms, 4 and 10. So negative 5x plus 14 less than or equal to 24. Let's move the constant terms to the right-hand side. So we get negative 5x less than or equal to 10. Divide away that negative 5, and again, we're going to change the direction of that inequality. So x is greater than or equal to negative 2. Okay. There's my value of negative 2. My solution is greater than or equal to negative 2. So instead of a closed circle, we want a bracket. And pointing to the right and shading to the right. And adding those infinities onto the number line, we can see that the 2 values that are shaded are the negative 2 and the infinity. So my solution interval is negative 2 up to infinity with a square bracket on the negative 2. So that's how we'll format our answer. All right, so let's do a couple more. Here's number 7. With this, we have a compound inequality. We have 2 of those inequality symbols. And so we need to start off by combining like terms in the middle. And we'll do that with the terms of x. All right, so that starts us off there. So now we have a single term of x in the center. Let's work to isolate that variable. So I have this constant term of 7. We need to get rid of that. So we're going to do its opposite by subtracting. Remember that when you're doing this, you have to subtract that 7 on the right side as well as on the left side. And so we have negative 8 on the left, less than 2x, which in turn is less than or equal to 2. Now we'll divide away the coefficient of 2. So remember, you have to divide that on the left side, divide that on the right side, and we get a negative 4, less than x, less than or equal to 1. So now that I have 2 values on my number line, now I want a sense of scale, okay? So now we have to think a little bit more about the tick marks here and where we're going to see this, because we do want to plot these brackets in the correct place using the scale that we have. Here we're starting at negative 4. That's a less than sign, so we want the curved bracket pointing to the right. Here at 1, that's a less than or equal to sign, so that's a square bracket pointing to the left. And so we shade in between. So that's going to be what our solution interval looks like. Our solution interval will be a rounded bracket, negative 4, separated by a comma, there's positive 1 with the square bracket. So that's our solution. Let me jump over to number 9. There's an added twist to this one that we need to talk about. But like before, we need to distribute that negative 3 so that we can have a single term, and then we'll combine like terms before we start adding and subtracting to all sides here. So the negative 8 stays where it is. We have the less than or equal to. There's the 1. Let's distribute that negative 3. So negative 3x and a plus 6. That's less than 13. Let's combine the like terms. So we have negative 8 less than or equal to negative 3x plus 7. Less than 13. Now we're ready to start isolating the variable. And I'm starting by subtracting 7 from each side. So negative 15 less than or equal to negative 3x less than 6. To isolate the variable, we need to divide away that coefficient of negative 3, both on the left and on the right. But because it's a negative number, you have to change the direction of those inequalities. So we have 5 greater than or equal to x, which in turn is greater than negative 2. So up to this point, it's just been algebra. The last couple of steps have to do with formatting this, and we're not quite ready to leave it this way. When we have this sort of result, where you have a compound inequality, we always want the smallest number to be on the left and the biggest number to be on the right, because that's how we order it on a number line, right? We would not put 5 on the left. No, we would put negative 2 on the left and 5 on the right. So we're going to take this inequality and flip-flop it around. So the negative 2, I'll just continue writing down here in the margin, goes on the left, and the 5 goes on the right. And because we're flipping that around, that means that's going to change the direction of the inequalities again. So this is pointing to the negative 2. It still needs to point to the negative 2. So it looks like x is greater than negative 2. Now, as we flipped it around, negative 2 is less than x. Here, in the previous line, you see that this greater than or equal to sign is pointing away from the 5 and towards the x. So in the same way, we want this to point away from the 5 and towards the x. So as the negative 2 goes to the left and the 5 goes to the right, we're flip-flopping that around. That means the symbols are also changing the direction. It still means the same thing, but that way the numbers go from left to right, smaller to bigger, just like our number line does. So we want our rounded bracket at negative 2, square bracket at 5, we shade in between, and then the final answer in interval notation uses those brackets like this. There's our solution interval. And that's it for our examples today.